Okay, so in this video I just wanted to provide a quick summary for everything that we've done in terms of second order ODEs. Okay, so let's take a quick look at all the steps that we used in order to solve a second order ODE. Okay, so the first step that we took was to solve the fundamental solution. And to do that, we used the lambda function. And we also made the right hand side equal to 0. So we forced the system to be homogeneous. And if you're looking for a specific video based on the fundamental solution, if you check out my calculus playlist video 05.2, I'll go through an example very slowly. So after we found the fundamental solution, we looked for the particular solution, which is specific to the right hand side of the equation. So it was for the case where the equation was non-homogeneous. And once again, I'll go through that in a lot more detail in video 05.3 in the calculus playlist. Once we'd found both the fundamental and the particular solutions, we could formulate the general solution, which is just the case where the general solution, we called it x subscript g, was equal to our fundamental solution plus our particular solution, which we called subscript f and p respectively. And once we'd done that, we looked at solving an initial value problem, which is when you know what your initial at time 0 values are. Say x0 for example. And when we had two unknown constants, we also needed to know the initial value of the velocity as well, so we could solve for two unknown constants. And if you were looking for a specific video for solving initial value problems, calculus playlist 05.4 has everything you need to know. Okay, so if you follow these 4 steps, you should be able to solve any second order ordinary differential equation, at least in one dimension, as we have been doing throughout the series of these videos. The main kind of problem, if you like, that students often get stuck with is figuring out which general solution to use for their lambda equation. So let's take a look at the 3 possibilities that we've covered during this course. So the first one we looked at was where lambda 1 was not equal to lambda 2, and this had the general equation of some unknown constant, which we called c1, multiplied by e to the lambda 1t, plus another constant, c2, multiplied by e to the lambda 2t. And all the general solution is doing is covering every possibility that could occur from our lambda results. So here, since lambda 1 is not equal to lambda 2, that means that the general equation, all it's doing is accounting for every possibility, since lambda could equal lambda 1 and lambda could equal lambda 2. Hopefully that makes sense. The second case that we looked at was where lambda 1 equaled lambda 2, where we just called it lambda, and the general solution to this was, again, some unknown constant c1 times e to the lambda t, plus another unknown constant c2 times t e to the lambda t. And this t here in the second term is the only difference between these two general solutions. And the third and final result that we looked at was the case where lambda is equal to some real value mu here, plus or minus some complex or imaginary value nu here. So this is the result that lambda is just some complex number. And we saw that the general solution in this case was e to the t. Again, we used c1 here, times the cosine function of nu t, plus another constant that we don't know, c2, times the sine function of nu t as well. And I mentioned in the video that this comes from Euler's relations. Well, it's true, so this is covering every possible solution that this might have. So if you can manage to remember everything that's on this summary sheet here, you should do absolutely fine with any question related to second-order ordinary differential equations in your exams. Of course, this course only covers the one-dimensional aspect. However, once you're comfortable with the steps involved in one dimension, it's quite easy to expand to greater numbers of dimensions. It just involves more initial values and unknown constants. Okay, so hopefully this video has helped you in some way. I just wanted to put together a kind of summary sheet just to kind of condense all of the information over the last few videos into one page. In the next video we're going to move on to partial differentiation, which is one of the most useful and the most common applications of differential calculus. As always, if you have any questions or comments, please feel free to pop them in the comments box below, and I will see you in the next video. Thanks for watching.